Now it's time to look at some curve sketching. This is really exciting because we're putting all these pieces we've been working on in the last few sections together to sketch a nice, beautiful picture. So one thing you want to keep in mind with this is there is not one right answer. There are several right answers, and that's okay. You can have a different answer than everybody else in the class, and yours can still be right. So I like it when math actually does that because it's nice to know whether you're right or wrong, but it's also nice to have more than one person be right. I think that's more fair. So let's just summarize everything we know so far. So if the first derivative is positive, the function is increasing. Back in first derivative world, positive meant increasing. The problem with increasing is it can look so many different ways. It could be a line, it could be a nice curve, it could be super steep, or not so much. It's not as helpful for curve sketching to know that it's increasing. Same thing, the first derivative being negative means decreasing, and it's still not so useful. We're falling left to right, but we can fall so many different ways, and it's just not as helpful. So when we get all this information that this section is going to give us, we want to remember if you're given a bunch of first information and second derivative information, really you're going to go more with what the second derivative is saying. That's way more helpful for finding the shape of a curve. So I'm going to put a star on these two. The second derivative being positive means the function's concave up. That really narrows things down for me. Concave up can only look three different ways. We've previewed this, so you already know it is a U, it is a left side of the U, or it is a right side of the U. Concave up only looks those three ways. Concave down will be an upside down U. It'll look like it's the left side or it's the right side. So it can only look a few different ways as well. We're going to use this when we draw some pictures. Before we draw some pictures based off the derivative, we need to figure out how we know a function is not differentiable. Not differentiable means it does not have a derivative. Differentiability means you can take the derivative of it. Differentiation is also the process of taking a derivative. So big word means you can't take the derivative if it's not differentiable. So where are we not going to have a derivative at all? Like we can't tell if it's positive or negative because we can't take it there. So graphically, one thing that doesn't have a derivative would be a discontinuity. This is some good test one review. We did some discontinuity already in this class. Discontinuity, there are three types that we talked about. We said jump. We could draw a picture of that. I'm not going to have a derivative where I'm jumping. I can't find the slope of that point because it is all over the place. It looks like it's increasing before and then increasing after, but not like the same slope. So where it has a jump, we don't know what the derivative is, just at that point. If we have an infinite discontinuity, same thing. Looks like a vertical asymptote. Yes, both pieces are increasing, but I can't find the derivative where there's a vertical asymptote. So any place where it is discontinuous. Our last type of discontinuity was removable. That's just an open circle. We don't know the slope at that circle because it's not colored in. So we have removable. That V looks very weird. Removable. There. So a discontinuity is not going to be differentiable. The second type of thing that is not going to be differentiable is a sharp corner. If you took calc in high school, this is also called a cusp. If you want to be fancy. I like calling it a sharp corner just because it looks like its name. So something like this. This is the absolute value function. It has a negative slope before and a positive slope after, but this change is so sharp, we don't really know what's happening there. If you took the derivative there, it would be undefined. This is a sharp corner. Or another way that this could look, we actually drew one just like this in the section before that had a derivative that was undefined because it looked like this. This is a sharp corner or a cusp. We don't know the derivative there, whatever you want to call it. it was negative, then it was positive. It had a relative min, but it's too sharp to tell what the derivative is. And we did this, it was like the 5th root of x to the 4th or something, and it had a cusp if you actually looked at a picture of it. Last thing is the hardest to draw. It's called a vertical tangent. It's where the slope is so steep it would be a vertical line to draw the slope there. And we've actually done one like this as well. If we look at the cube root of x, if you have a graphing calculator, you could use that, or if you pull up desmos.com, you can type in and see what the picture is. But the cube root of x, we've looked at this a couple times, and if you type in x to the 1/3 or the cube root of x, the graph looks like this. It goes from increasing to increasing, and this point here, it's like basically going straight up. So it has a vertical tangent line, so we can't find the derivative there. The slope would be undefined. It goes up too quickly. So we'll keep that in mind on these. If we're asked to draw something that's differentiable, we want to make sure it's not discontinuous, it doesn't have a sharp corner, and that it doesn't have a vertical tangent. So when it says continuous and differentiable, it just means, hey, avoid these 3 things if you want to be differentiable.